Hello everyone, hope you all are doing well. The video you are seeing is generated by a Stable Diffusion model, and the video is automatically generated through the Stable Diffusion video GitHub project. This is another video which is also creating using the Stable Diffusion video project, and this video is also created by the same library. So now you have understood that you could generate videos by using the Stable Diffusion open source AI model by providing your text prompt, and everything is being taken care by the Stable Diffusion open source model as well as the Stable Diffusion video GitHub project, which stitches all of these images generated by Stable Diffusion model itself, and the video is available for you. So I do have a Google Colab environment running Python, Jupyter Notebook, and here is the Stable Diffusion Videos GitHub library, which we are going to use to build the videos. So the Stable Diffusion video is already available as a pip package. So we could install it, pip install. And if you look into the release version of Stable Diffusion video, you will be seeing that this library also support the real ESR GAN. It means that you can also install the real ESR GAN package along with Stable Diffusion video. It means that we are installing the real ESR GAN based Stable Diffusion videos package. The packages are installed. Look into the pip show Stable Diffusion video. Here you could see that is using the fire transformers diffusers, and this is very important to know because looking into the Hugging Face diffusers, you will find that this is the state-of-art diffusion models for image and audio generation in PyTorch. This is a PyTorch based library which is using the diffusion models for images and audio generations. That is what it is using along with Gradio and transformers, which are the Hugging Face transformers. In the next step, we are going to connect to the Hugging Face notebook logging. So from Hugging Face, we need to import notebook login. And once you get this method, now you can actually logging into your Hugging Face account. And now we need to launch it. And at this time, we need the Hugging Face personal token, not the business token. Logging into the Hugging Face, that's the account. You can go to your settings and you will be seeing your access tokens. So this is the token you really needed. I will be copying, pasting here, logging, and make sure you are using the personal access token, not the business access token. So now we need to import the interface, and that interface is available in Stable Diffusion video. So here is your Stable Diffusion videos. So we are importing. So from Stable Diffusion videos, we are importing interface, and that is the time where the packages related with the Stable Diffusion videos, these are all being downloaded from the Hugging Face model resources. So that is the reason we needed the access to Hugging Face. If you will not use your token, then you will be downloading the models individually, and logging to the notebook login environment gives us ability to download all the packages what we really needed in order to build the Stable Diffusion video interface. And all the modules and models related with Stable Diffusion and tokenizer, everything has been downloaded. And here we are using the Bird basic tokenizer instead of FTFY. And this interface which we are using is actually already available in Stable Diffusion videos. If you come here, look into the app, this is the interface which is available in the Stable Diffusion. So when we are going to use the interface object, we can actually use the interface.launch. So this is the interface which we have imported from the Stable Diffusion videos. So if you say interface.launch, here the launch method which is available here. So interface.launch, we can do the launch, and here if you would want to debug it, you can say debug equals true. That is exactly the entry point for the Stable Diffusion videos app.py. And this actually launcher uses the interface object, which is the tabbed interface. So there are two tabs, images and video. And for those images and video, there is an implementation for interface images. This function image for the interface images, and here's the interface videos and interface images, which actually connect to function images. Interface video connect to function videos. So here is the function video and here's the function images. So we can launch it. As soon as you will launch it, it's going to start the radio based interface. And here is the URL. We can take this and open it into a new tab, and that's where you can generate images or you can generate videos here. So image I will pass, and I will be showing you three parameters: guidance scale, the number of inference steps, and number of interpolation steps. So this is what control your number of images. So for example, I want to build a video. I can have the two of these prompts. So I can say prompt one, prompt here. So I could say watercolor image of sunflower. And here I could use the watercolor image of water lily. Guidance scale up to 20. We are using just middle 9. Inference steps, just make it less even. So about 20. The output is going to be stored into the dreams folder, and that folder will be available at here in this samples data. Let's run it. Process is started. This is the dreams folder. If we go back, content, there's the dreams folder. That's where the process for generating video has started. And here you could see that images are being generated. So based on the request, each image will be generated here, 0, 1, 2. If we click on here, we could actually see the images output as well. That's the very first image, second image, and now it's water lily, and fifth image. So there are 6 images, 0 to 5 index. So all of these images are generated. We could see here. And then the Stable Diffusion video library already uses the pipeline to convert it into a video. So here you see that a video is also generated. And if we look into our UI, the video is available here. And if you play, this is how you will be able to see that our video is created. So you can get an idea that how quickly just writing a few lines of code in your notebook, you could actually use the radio-based interface to generate the video from your text prompts. And that's one way to generate your videos. If you would want to download the videos, you can click here, you can select a video and download. And that's how you will be able to download your video from Google Colab to your local file system. And here is the video. Now we are going to use the another way to create the videos. And in this scenario, we are not going to use the interface. Instead, we are going to write the code directly. Means we are going to create the Stable Diffusion walk pipeline. So let me runtime interrupt it. So first thing first, ability to show the videos in this Jupyter tab. That's why we are using this HTML, import HTML. Next, we are going to use the from Stable Diffusion videos. We are importing the Stable Diffusion walk pipeline because this is what we are going to use. And if you look into the Stable Diffusion video, where the video is really being created, you will be seeing that actually this library itself is using the Stable Diffusion walk pipeline. So we are manually using the Stable Diffusion walk pipeline. Next, from diff users. So diff users is, I have already shown you, it's coming out from the diffuser, which is a very latest model coming out from Hugging Face. So we are using the from diffusers dot schedulers port LMS discrete scheduler, and we are importing the PyTorch. So these are the modules we needed in order to build our own walk pipeline using Stable Diffusion video. Let's build the pipeline. So we can say pipeline equals, this is our module, so Stable Diffusion walk pipeline dot, we need to say from pre-trained. So let's start from here. First, we need to pass the model, and model we are going to use from Hugging Face, and the model will be Stable Diffusion. So you can say comp with Stable Diffusion Hugging Face. So this is the comp with Stable Diffusion, and looking into the model card here, you can get all the details which model. So the model will be comp with Stable Diffusion here, and then we need to provide the version, so v1 and 4. That you can also learn from here that they have v1 4. So this is the latest which supports resolution up to 512. And if you need to make images bigger than that, you need to upsample it. So that's where our model has been defined. Next, you need to say use auth token true torch d type we need to provide, and we can say that for that one we are using the torch dot float 16 revision floating point 16. We need to provide the scheduler lms, that's where we have imported here lms discrete scheduler, and we need to provide the different parameters. So if you would want to know the lms is discrete scheduler, you see here these are the parameters which we will be using. So let's take them as it is. Beta start 000 0.00085, beta end 0.012, scaled linear, and number of trend steps. If you would want, we can keep them or we can remove them. So that's where our scheduler. So we have set up the pipeline. This is the pipeline variable. Now because we are creating this pipeline on Google Colab, it means we have access to CUDA, so we could actually make sure that this pipeline is actually available on CUDA. So in order to make sure that this pipeline is actually created in CUDA, actually there is a typo, I'm going to fix this. You can say 2 and you can put CUDA and rerun it. So now this object is going to make sure that it is available on the CUDA. Now if we launch this NVIDIA SMI application, that's where how you will know that the machine which we have already has access to CUDA runtime. Now our pipeline is ready. If we check the pipeline, that's the Stable Diffusion walk pipeline. Here all the configuration or the parameter related to it. Next, we are going to use the pipeline and create the walk method. So you look into pipeline dot, you see walk is available, and now we need to provide the parameter. So very first thing what we need is the prompt. So we can say a horse, then a zebra, donkey, pony. We can say a wild horse, a pony, gray horse. So first, these are the 5 images we are using. Then we need to provide the seed for each one. That's the seed. Then remember when we were using, we need to provide the number of interpolation steps. You can say I need 5. We need to provide the height and width 512. Let's run. Let me stop it 1 second before we run, because the output of this pipeline will be the video path. So we need to make sure the output of this pipeline is the output video path. Now our images are being generated. So now the processing has been completed. So you can come here. You can look into the viewer. So when you have the video path, this video path you could use to see the video. We are going to create a method, visualize the video collab. Here we are going to open the video path. So let's launch this method. Now call this method and pass our video path. Run it. So this is the video is being loaded, and that's where the horse. Now we are going to create a video which will also going to have the audio built into. So here we have a futuristic landscape, and here we could say a realistic landscape. So we are using 2 prompt. At this point we can use this suggestion. So here is our audio offset. We can use audio offset here. So that's where our audio offset. So we have audio offset, and there is a number of interpolation images, and we can use this value rather than that. Now we can also use the audio as well as audio file path, audio start time. we are using. So I just need to provide the audio. So I need to upload an audio file from my local file system. So in the content folder, I have uploaded this guitar.mp3 content/guitar. So that will be our audio file path. And we can create the output folder also. So we can use output here and we call it landscape, and rest of this guidance scale as well as the inference stop, both of them as it is. At this point, our prompt is ready to be launched. We can make sure that what's the size of interpolation steps we are getting here, and it is 60. It means it's going to take quite long. So just for now, what we could do, just to make sure that rather than using this, because we need to show the fast access, so rather than using interpolation step, I will just make it 10 and do not use this parameter because we want to expedite our delivery. So we can run it now. So here is our landscape folder. Based on our number of interpolation steps, here are the images. And if we look into our landscape folder, you are going to see the images, and here is the final video. We can play the video with using the same method here. This function is already being declared. So let's launch it the video. The code which we have covered in this Jupyter notebook is going to be available in this Stable Diffusion video folder, is available in this Stable Diffusion video folder. So that's all we have to cover in this video. I hope you have enjoyed the content and found something useful where you could get yourself started by using either Stable Diffusion model or just Stable Diffusion videos creation GitHub project and get yourself started. I do appreciate your time, and I'm looking forward to seeing you in my next video. Until then, thank you so much.